Hi, this is Shannon Seaver. Today we're going to look at linear functions and their graphs. This is part A of section 7.2 of our book. On our agenda is to use intercepts to graph linear equation, calculate the slope, and use the slope and y-intercept to graph a line. There are three types of linear functions. We have standard form, and standard form is shown to you by ax plus by equals c. There's slope-intercept form, which is in y equals mx plus b. And note that in this form, m is the slope of the line, and b is the y-intercept. And then the last one is the point-slope form of the line. Sometimes you're given a slope and a point, but not the y-intercept, and you can use this form to make your equation. So yp and xp stand for a slope of a point, a coordinates of some point that's been given to you. So I'm going to just call it xp, yp. And then this is the slope. We're going to talk about mostly these two in this course, and sometimes this might come up, but these are the two that we're focusing on in this chapter. First of all, we're going to talk about graphing using intercepts. We're going to locate the x-intercept by setting y equal to 0 in the equation. So we have an equation here. We want to set y equal to 0. So when I do that, it becomes like this. And notice that 3 times 0 is 0. This virtually just goes away. So I'm left with 5x equals 15. Now if I solve for x, I'm going to divide both sides by 5, and I get x equals 3. So x equals 3 is my x-intercept. I can go over to my x-axis and put a point right there on 3. Now I want to do the same thing for y. And in order to do that, I need to set x equal to 0. So here I have 5 times 0 plus 3 times y equals 15. And notice that 5 times 0 is 0, so this disappears. I'm left with 3y equals 15. I can divide both sides by 3, and then I have y equals to 5. So I can put a decimal, or not a decimal, a point here. Now I have 2 points, and because I have 2 points, I can actually draw my line. In your notebooks, when you do this, you should use a straight edge so you can draw a straight line. I'll do the best I can here on the screen. So there, we have our line. Now I want you to take a moment to try to do it yourself. Come back and check on the video when you're finished. Okay, so on this one I have x equal 2 as my x-intercept and y equal 3 as my y-intercept, and if you notice, I connected the dots and made my line, and that is how we graph it by intercepts. So now I want to talk to you about slope. If I have 2 points and I connect them by a line, I have a slope. So if you look at these 2 points here, I have x1, y1, x2, y2. And you notice that the slope of the line is the difference between the y's and the x's. So here I have the rise. So if I go up, that's a rise over the run. So the difference in the y's, y2 minus y1 over x2 minus x1. And notice that we have to say that x2 minus x1 cannot be 0. If it was 0, it would be undefined. Alright, so now we're going to find the slope between these 2 points. So I have -3, -1, so this is my x1, y1. This is my x2, y2. So if I take y2 minus y1 over x2 minus x1, I get 4 minus a minus 1 over -2 minus a minus 3. So I have 5 on top because this negative and negative makes it a positive. I have a negative and negative here, so it's the same as saying negative 2 plus 3. This will be a 1. So in this case, my slope is 5. 5 divided by 1 is 5. I'm going to pause the video. I want you to take time to try the next 2 coordinates to find the slope between them. Okay, on these 2 points, we got a slope of negative 6 over 5. There are 4 types of slopes that are possible with a line. If you notice, we have this slope right here. It's called a negative slope. One way I remember that it's negative is if I were to make 2 parallel lines at the beginning and end of it, it forms the shape of an N, which is the start of negative. Hopefully that can help you remember that anytime you can make an N out of the line, it's a negative slope. This one is a positive slope. It's going in the positive X direction and the positive Y direction. This one's undefined. I kind of like to think of this as if I put a little man here or a little woman right here at the top of my my line, like a cliff, what would happen to that person if they were to go over that cliff? Well, they would go splat, right? So that makes them undefined because they would not have any shape anymore if they were to fall at the bottom of that cliff. So that's an undefined slope. This one is no slope. Have you ever noticed that when you're riding an exercise bike or just a bike in general and you're going flat, it seems to take no effort? Well, that's because there's no slope. So here, no slope is the easiest one, aside from going downhill like the negative slope. The other form that we want to talk about for the types of lines is the slope-intercept form. And I talked a little bit about this at the beginning of the video. This is slope, and this is your intercept when x is 0, y-intercept. Okay? So if I were to graph a something with slope-intercept form, first I'm going to do is I'm going to plot my y-intercept, put a point there. And then from that point, I'm going to find another point using the slope, my rise over run, to get to my next point. And then I would use a straight edge to draw the line. So let's do an example. Here I have 3x minus 4. Minus 4 is my y-intercept. So I'm going to go to the y-axis and go down to negative 4 and plot a point right there. 3 is my slope. That's the same thing as saying 3 over 1. And that means my rise is 3, so I'm going to go up 3, 1, 2, 3, and run 1. I can do that again if I wanted to and keep going and make a series of points, but you really only need 2 points and a straight edge to draw this. Being that I don't have a straight edge, I'm just going to go ahead and plot a few more points just so I can guide my hand. But here we go. Notice that I can't draw a straight line. So, but you get the point. It should be going through those points. Notice that this one is not in slope-intercept form. I could graph this one based on the intercepts because it's set up this way. It's a little bit easier to do sometimes. I could cancel out the 5y by putting 0 in for y. Then I'd have 2x equals 15, or x equals 15 over 2, which is 7.5. Could do the same thing for the y, canceling out the x, so it'd be 5y equals 15, or y equals 3. So I could go over to 3 on the y and 7.5, which doesn't quite fit on this particular graph, but we can estimate it as right here and draw our line. Another way we could do this is to solve for y and put it in slope-intercept form. If I wanted to get y by itself, I'm going to subtract 2x from both sides. So I'm going to have 5y equals negative 2x plus 15. And now I want to get y by itself. So I would divide everything by 5. And y is the same as saying negative 2/5 x plus 3. So I could have graphed this by using the slope-intercept. I'm going to erase what I have here. Starting off with 3 as my intercept, and then I want to fall, because it's a negative, instead of rise, I'm going to fall 2. So go down 2 over 5. 1, 2, 3, 4, 5. And here's my next point. And then I could have drawn that. And it would have given us the exact same result as the very first way that we graphed it. So whichever way works easier for you, you can graph by intercept, or you can solve for y and graph by slope-intercept. I want you to take a moment now to see what you get if you graph this one. This one you will have to graph by slope-intercept because we have it equal to 0. You will not be able to graph it by x-intercept and y-intercept. Okay, so if you solve for y, you get, I'm going to take away 3x from both sides. So I'll have negative 5y equals negative 3x. And divide by negative 5. So y equals 3/5 x. Notice that I have no intercept here. I could almost say, or I can say, it's 0. So I'm going to start at 0. I'm going to rise 3, 1, 2, 3, run 5. 1, 2, 3, 4, 5. So here we have our 5. If I graph this, it should look something like that. That is the end of this video. If you have any questions from today, please bring them to class tomorrow.